Today, we're diving headfirst into a topic that feels like science fiction, but is rapidly becoming a reality: quantum computing. For years, it's been this nebulous futuristic concept, right? But in 2025, we're seeing some genuinely mind-blowing advancements. So, if you're a software engineer, a tech enthusiast, or just plain curious, you need to know, are we as programmers ready for the quantum leap? And more importantly, what does this mean for our industry? Stick around, because by the end of this video, you'll have a much clearer picture of what quantum computing is, why it matters, and how you can start to dip your toes into this incredible new world. First things first, let's demystify it. At its core, traditional computers like the one you're watching this on use bits. A bit is either a 0 or a 1. Simple, definitive. Quantum computers, however, use qubits, and here's where it gets wild. A qubit can be a 0, a 1, or get this, both a 0 and a 1 at the same time. This is called superposition. Think of it like that spinning coin. Until it lands, it's simultaneously heads and tails. And it gets even crazier with entanglement. If two qubits are entangled, the state of one instantly affects the state of the other, no matter how far apart they are. Einstein called it spooky action at a distance, and it's this fundamental property that allows quantum computers to perform computations in ways classical computers simply cannot. These two properties, superposition and entanglement, mean that as you add more qubits, the computational power doesn't just add up, it grows exponentially. A quantum computer with just a few dozen qubits can potentially explore more possibilities simultaneously than all the classical supercomputers on Earth combined. Okay, mind-bending physics aside, why should you, a software engineer, care? Because quantum computing isn't about replacing your laptop, it's about solving problems that are currently intractable for even the most powerful classical machines. One, drug discovery and materials science. Imagine simulating molecular interactions at an atomic level to design new drugs or super efficient materials. Quantum computers could revolutionize healthcare and manufacturing. 2. Financial modeling and optimization. Think about optimizing complex portfolios, predicting market fluctuations, or even designing more efficient logistics routes. Businesses are itching for this. 3. Artificial intelligence and machine learning. While AI is already powerful, quantum AI could train models exponentially faster, handle far more complex datasets, and discover patterns currently hidden from us. Cryptography and cybersecurity, well, this is really a double-edged sword. Quantum computers could, actually break many of our current encryption standards like RSA. That's exactly why research into post-quantum cryptography is absolutely booming right now. We need brand new ways to secure our data against those future quantum attacks. So while your everyday web app isn't going quantum tomorrow, the underlying infrastructure, security, and the very problems we can solve in the future will be profoundly impacted. Now, let's talk about why 2025 is a particularly interesting year for this topic. We're seeing quantum hardware mature significantly. Companies like IBM, Google, and Quantum are making steady progress on increasing stable qubit counts and critically improving quantum error correction. This is huge because honestly, qubits are notoriously fragile. Better error correction means more reliable computations. You no longer need your own quantum computer. AWS Bracket, IBM Quantum Experience, Azure Quantum, these platforms allow you to write and run quantum code on real quantum hardware in the cloud. This kind of democratization is really accelerating research and learning. The industry isn't just chasing bigger machines, they're pinpointing specific real-world problems where even early quantum computers can show a demonstrable advantage over classical ones. This makes the R&D much more focused and practical, and now we're moving beyond pure theoretical physics and into engineering challenges, which is where software engineers truly shine. So, how do a classical software developer start to play in this quantum sandbox? Good news, you don't need a PhD in quantum mechanics to begin. The primary way we interact with quantum computers right now is through high-level programming languages and SDKs. The most popular ones you'll encounter are first, Qiskit from IBM, which is Python based, extremely popular, has excellent documentation and a huge community. Second, Cirq from Google, which is also Python based and designed for flexibility and ease of use with quantum algorithms. And then there's Microsoft's qubit, a standalone language integrated with the .NET ecosystem, offering a more traditional programming feel for some. So, what does the future hold? Are quantum computers going to replace classical ones? Not really. Think of them as accelerators for specific, incredibly hard problems. They'll work in tandem with classical systems, much like GPUs accelerate AI workloads today. Your role as a software engineer will evolve. You might not be writing quantum algorithms daily, but understanding the fundamentals will be crucial for identifying quantum solvable problems. Knowing when a problem is a candidate for quantum acceleration, also integrating quantum solutions, bridging the gap between classical applications and quantum backend services, and developing post-quantum secure systems, designing the next generation of encryption. The quantum revolution isn't a distant dream anymore. It's happening, and it's happening fast. Being aware, starting to learn the basics, and understanding its implications will position you at the forefront of the next wave of technological innovation. And that's our quantum leap for today. I hope this video has given you a clearer, more practical understanding of quantum computing in 2025. It's an incredibly exciting field with the potential to redefine what's possible in software and tech. What are your thoughts on quantum computing? Are you excited, skeptical, or already learning Qiskit? Let me know in the comments below. I love reading your insights. If you found this video helpful, please hit that like button, subscribe if you haven't already, and ring that notification bell so you don't miss our next deep dive into the world of tech. Thanks for watching, and I'll catch you in the next one.